safety precautions in the laboratory.
Laboratory safety is essential to prevent accidents, protect equipment, and ensure all practical activities are conducted safely and effectively.
First, students must wear proper personal protective equipment or PPE before entering the laboratory.
This includes a lab coat, safety shoes, and safety goggles to protect against electrical, chemical, and mechanical hazards.
Long hair should be tied properly or loose. Accessories must be avoided.
Before starting any experiment, students must read and understand the laboratory manual and experiment procedure.
Always follow instructions given by lecturers or lab technicians and never operate equipment without authorization. In electrical and electronic laboratories, safety procedures are extremely important.
Ensure the power supply is switched off before assembling or modifying any circuit.
Check cables, socket, and equipment conditions to prevent short circuits or electric shock.
Never handle electrical equipment with wet hands.
Use all instruments such as multimeters, oscilloscope, and power supplies according to standard operating procedures.
Avoid misuse of equipment as it may cause damage or inaccurate measurement results.
After completing the experiment, return all equipment to its designated places. Students must know the location of emergency equipment such as fire extinguishers, emergency exits, and first aid kits.
Any accident or injury or equipment malfunction must be reported immediately to the lecturer or laboratory assistant.
In conclusion, following laboratory safety precautions ensures a safety, efficient, and professional learning environment.
Safety awareness reflects good engineering practice and responsible student behavior.
Most diodes have a band or strip marking on one side of the body. The strip side represents the cathode terminal. The opposite sides without the strip represents the anode terminal. For lead diodes, longer lead equal to anode, shorter lead or flat edge equal to cathode. This method is simple and fast. However, sometimes the marking becomes unclear or damaged. Therefore, engineers use a more accurate method using a measuring instrument, which is the analog multimeter.
Now, we will identify the diode terminals using an analog multimeter. First, set the multimeter selector switch to resistance mode. We select the range 1, 10, or 100. Before the measurement, touch the red and black probes together. Adjust the zero knob until the pointer moves to 0 ohm. In analog multimeter, probe polarity is reversed. Black probe is positive, red probe is negative. Connect black probe to one terminal. Connect red probe to another terminal. If the pointer moves toward low resistance current flows, this condition is called forward bias. Therefore, black probe connected to anode, red probe connected to cathode. Next, reverse the probe connection. If the pointer shows no movement, very high resistance, this is reverse bias, meaning the diode blocks current.